Okay, this is where we left off on Friday in section 1.4, piecewise defined functions. Another thing you saw in Algebra 2. So let me show you how we evaluate these and introduce piecewise functions. There's a good application problem on page 42 I have ready right here, so we can take a look at it. This just goes over the number of fuel stations that sold E85 in the United States from 2008 to 2011. But then it increased and there was a different pattern, a different linear pattern from this time span. Okay, so what they created was two different equations. Why? Because they had a different linear pattern on these years. Okay, and they let 8 represent 2008 and so on. 11 represent 2011. Okay, so when you're asked to evaluate and figure out the number of fuel stations in 2014, which equation would be appropriate? This one down here. You always want to look at the domain first, okay? Because this is the pattern that exists for that time frame. If they said figure it out for 2009, then we don't want to use this equation. We want to use the one associated with that. Okay, so that's what piecewise functions are all about, just figuring out the domain first, or which of the, they call it subfunctions here in our notes, which of the subfunctions we're supposed to use, okay? So you always want to start right here. Start with the domain. I'm going to make note of that here. Start here with the domain. Which of these are true, basically? So the directions say to evaluate these piecewise functions at the given values of the independent variable, which means x, right? It's our input value. So for part A, we're given an x value of -3. So we start here and decide which of these conditions are true. Is -3 less than or equal to -1? I'm sorry, why did I say negative? +1. Yes, it is less than 1. It clearly is not greater than 1. So this is the condition it satisfies. So since -3 is less than or equal to 1, we use the first line, right? We use 2x minus 3. Okay. All right, so f -3 is going to be 2 times -3 minus 3. Okay, and then we get -6, take away 3, we get -9. Part B. 1. Which of these inequalities matches with 1? Is 1 less than or equal to 1, or is 1 greater than 1? 1's not greater than 1, but it is less than or equal to 1. So back to the first equation. So we ignore the bottom line, and all we're doing is kind of using this top line here for this. So f of 1 is going to be 2 times 1 minus 3. So we get -1. Okay, and the last one, if we look at 3, analyze it, which is true. When you plug 3 in here, 3 is greater than 1. Okay, so now I'm writing all over this, but really, since that's true, we're just dealing with this scenario, right? That's it. We can ignore the top line. Okay, so f of 3 is going to be 4 minus x. So in this case, 4 minus 3. That's it. Condition first, determine which one satisfies, and then use that equation. Try it for 12. Okay, here we go. -4. -4 is less than -2. Clearly, -4 is not greater than or equal to -2. Since it's less than -2 or further to the left on the number line, we use the top line here. Okay, so we get 13. If you didn't get 13, maybe you used the wrong equation, or maybe you squared -4 incorrectly. All right, next one. -2 is greater than or equal to -2. So use the second line now. We get 5. And here's C. We should use the second line for this one as well. 3 minus 8. Okay, next set of questions. Really just some function notation questions. We're evaluating functions when they give us these different scenarios. This one says when f of x equals 0, and then this one down here, they change it to f of x equals g of x. All right, so find all real values of x for which f of x or y equals 0. Remember, whenever they give you f of x, we can always replace it with y. Okay, so we just got to set or replace f of x with 0 here and solve it. That's it. Or if you want to see it again, what values of x will give us 0 for our function? Okay, so we just got to solve it and react to what we have. Sometimes we'll have quadratics like 14. Sometimes we'll have a simple linear equation like this one. So let's get x by itself. Positive 4 is the answer. Okay, you pause and try 14. This one's quadratic, and we reviewed these steps for our warm-up today and last Thursday. Okay, so once you find the factors of negative 24 that add up to negative 5, we can use that to split the middle term and factor by grouping if you want. But since the shortcut exists, we can, since a is 1, shortcut exists, we can jump to these factors right here. Now we set both of these equal to 0 to finish. Okay, so there's the values of x that make this function 0. Okay, 15 and 16. I'm just going to stick with one of these for now so we can get to the domain problems next, because 15 and 16 are very similar in nature. Yeah, Ivy helped me with it a little bit when we get it going. All right, so this basically, we can use substitution if this helps as well, but we just want to set these functions equal to each other and solve for x. Or you can look at it this way. Take x squared plus 1, substitute it in the left side, take this, set it in the right side. Okay, so for quadratics, it's always good to set it equal to 0 first. If you want to make note of that, set equal to 0. It's a good first step for really anything. Even if it's linear or cubic, you could always set it equal to 0 to start and then figure it out from there. Okay, now it's also good to keep a positive. What I mean by that is I could subtract x squared to the right side, but then I'd have negative 2x squared. It's hard to factor and do these steps when a is negative. So we always want to keep a positive. So I'm going to make note of that too. Keep a greater than 0. So that would mean I'd want to take this minus x squared and add it to both sides. So I get 2x squared. I'm going to do 2 steps in one. If it's too much, I guess just rewrite it as 2x squared plus 1 equals 3x. You know what, I will just in case. All right, what I was going to do is maybe just move the 3x over on that step, but I'll do it now. Okay, and here we are, where we have to solve a quadratic again that we reviewed last Thursday. Okay, so I'm looking for no shortcut now. I've got to split the middle term or guess and check. So factors of 2 that have a sum of negative 3. I'm pretty limited on my factors of 2, right? I've got 1 times 2. That adds up to 3. So I need both of them to be negative to get a sum of negative 3. And that still works for my factors of positive 2. Okay, so now I know, I'm just going to draw a dividing line to separate that. Now I know how to split my middle term using these two numbers right here. So this is now going to be 2x squared minus 2x minus 1x plus 1. Okay, I'm going to take the GCF out of this group and then the GCF out of this group. So here I can take a 2x out. So I was going to maybe let you finish it, but let's just finish it together. I'm going to take, remember, whatever sign is in front of the next group has to transfer down. And if you can't take anything out, you at least have to take a 1 out. So in this case, it's -1. So we're filling in the blank. -1 times what gives me +1. I need this to be a -1. Okay, almost completely factored now. So now that I have x minus 1 in common, that comes out of each group. So once I pull out the x minus 1, I'm left with 2x minus 1. So those are my factors. I'll just continue right here. So we get x minus 1 times the quantity 2x minus 1 equals 0. Set them equal to 0 and finish. Add 1. This one has 2 steps. So when I add 1, I get 2x equals 1. And then we divide by 2. So we get 1/2. Okay, let's skip 16 for now. You have 1 or 2 of these in your OTI where you can practice these quadratic skills. So I want to get to the last learning target of the finding domains of functions. Okay, so to find domains of functions, the first thing you want to realize that they want you to figure out what values of x will work. Okay, so it's really kind of what you're looking for. What x values will work? Question mark. So what won't work? Well, these are some scenarios that won't work. You can't divide by 0 in math. If you grab your calculator and hit 8 divided by 0, it gives you an error message. Okay? So because we can't divide by 0, what you want to do, so I'd add this bullet here. When an expression is in the denominator, I'm just going to say denominator, like 18 and 22 and 21 that I'm looking at below there. When an expression is in the denominator, sets the denominator, I'm going to abbreviate it this time, set the denominator equal to 0 to check for restrictions. Okay. So with that in mind, we'll get to the even root of a negative number in just a second, but this is enough to try 17 and 18. 17, I do not see an expression in the denominator. So we are all set. There's nothing wrong with this. There is no restrictions on the domain. If you wanted to look at the graph, it would be a parabola that continues for all x in both directions, and we're good to go. So you can write out in words all real numbers if you want, or you can use the interval notation you were taught last year, parentheses, -infinity to +infinity. Okay. All right, by 18 though, we have a problem. We can't divide by 0, so in order to handle that and figure out what gives us 0, we are going to set the denominator equal to 0 to check for those restrictions. So whatever's down here, you kind of go off to the side, set it equal to 0, and solve it. I'm going to stop here and continue this on the next video.